Hi, my name is Igor Vinograd, and I am an electrical engineering student at the University of Akron. I put this video together to tell you some things about my extracurricular activities. I'm on a robotics team that competes in the NASA robotic mining competition. I've been with the team for about 2.5 years, and at last year's competition, our team placed third overall. We hope to do better this year. With the team, I've done lots of different things, software, hardware. Currently, I am heading up the electrical design team. And the thing I'm most proud of is implementing a new internal communication system. Our robot has 6 processors that all need to talk to each other and need to talk to a Wi-Fi link back to the control box. And we were having issues with our internal communications. The system was a mixture of half duplex and full duplex, and the thing we had the most problems with was latency. We had to do a lot of hand tuning of the software to make sure that messages were arriving on time from processor to another processor. The idea I came up with to solve the issue is to implement a router processor, a processor that was specifically dedicated to communications. The high-level layout looks like this, where the processor would be at the center of a star network system, and when a message would come in, it would check the message to see where the message needed to go and then send it out. For example, if a message came in from the Wi-Fi that was going to the motor controller, it would then be forwarded to the motor controller. The communications library we're using before was called Easy Transfer, and it was written by Bill Porter. I used this library as a starting off point, and I wrote my own. Things that I added to it included individual module addressing, variable packet length, and automatic ACK-NACK response. After I wrote the library, I wanted to do a proof of concept, a physical example of what my idea could do. So I found a PIC32 microcontroller that had 6 hardware UARTs. This would allow me to route all of the communications on our robot. To do the proof of concept, I designed a development board. This is it, where it has the PIC32 on it, and I broke out all 6 UARTs so that I could, once I wrote the software for the router, I could test it. And I did. I hooked up 4 Arduinos and I ping-ponged a message between them for about an hour with no issues. We are implementing the system on this year's robot. We have designed all of our boards, and we'll be sending them out for manufacturing here in a couple of weeks. Some things that I'm looking forward to try is that this processor also incorporates USB support. And I would like to be able to debug any processor connected to it out through the USB, where we could have a central point for debugging of any processor on the robot. Another thing is that I incorporated a lot of error detection into the communications protocol, that anytime any kind of error occurs, a counter is incremented. And something I'm curious to try is to have the system automatically time its communications by using the error as a reference, so that if the error counter starts counting up, it would know to slow down its communications. That way all of our comms could run as quickly as possible. That's just a little taste of some of the things that I do, and I would like to thank you for considering me for this intern opportunity. Thank you.